Preparation of amines. First method from alkyl halides. And this process is known as ammonolysis. Okay. In this reaction, ethanolic solution of ammonia are heated with an alkyl halide in a sealed tube under pressure and at 373 Kelvin. Okay, 373 Kelvin. Reaction takes place, nucleophilic substitution reaction takes place, and halogen atom in the alkyl halide is replaced by NH2 group. Okay, and this process is known as ammonolysis because here the splitting of ammonia is taking place. Let us see the reaction here. Okay, like this. So the product will be RNH3 plus X minus. Okay, a substituted ammonium salt is obtained. Substituted ammonium salt, from which different products like primary amines, secondary amines, tertiary amines and quaternary amines are obtained, and a mixture of all these products are obtained. Okay, and we can obtain free amine if we add this salt with sodium hydroxide, we will get free amine. Okay, reaction will be like this: RNH2 plus H2O plus NaX. Okay, now these primary amines are first obtained. The reaction will be like this. Then it reacts with the Rx present in the mixture and next obtained R2NH. Then again it reacts with Rx and form R3N. Again it reacts with Rx and form R4N plus X minus. Okay, all these products are seen in the mixture. Okay, so a mixture of primary, secondary, tertiary and quaternary salts are obtained. Okay, if we are using ammonia in excess, we will get primary amine, and the reactivity order of different halogens will be like this. Ri is more reactive than RBr, which will be more reactive than RCl. This will be the order of reactivity. Okay, in laboratories and all we are using Ri because it is easy to handle, but for commercial purposes we are using RBr because RBr is cheaper compared to others. Okay, this is the first reaction. Next, second one is from nitro compounds. Okay, from nitro compounds, how can we obtain amines from nitro compounds? Here the reduction of nitro compounds are taking place. Nitro compounds are reduced to primary amines by different metals like zinc and in presence of HCl, or iron in presence of HCl, then tin in presence of HCl, or lithium aluminium hydride. Okay, or we are using catalytic hydrogenation takes place. Okay, hydrogenation in presence of nickel, palladium or platinum. Okay, these are the different reagents used for this reaction, and the reaction will be like this. With aliphatic amines on reduction, if you are using zinc and HCl, reaction will be like this: C2H5 NH2. So NO2 gets reduced. Okay, now nitro compounds are also reduced by passing hydrogen gas in presence of nickel, palladium or platinum. Okay, so in the case of aromatic compounds, NO2, if if you are taking hydrogen gas with palladium, presence of ethanol, this gets reduced to aniline. Okay. Similarly, this nitro compound can also be reduced with tin HCl or iron HCl. Okay. Again, aniline will be obtained. Okay. So, different products, reduction will take place in presence of different reagents. Okay. And the reduction of iron and HCl is more preferred because in this case only a small amount of HCl can be used, and also FeCl to obtain during this reaction can be hydrolyzed and give HCl. Okay. Next reaction is from alkyl cyanides. And isocyanides. Okay. Here also the reduction takes place. Okay. The alkyl cyanide or isocyanide is reduced in the presence of hydrogen gas with platinum or lithium aluminium hydride or sodium in presence of ethanol. We can use any of these reagents. Okay. So, in the case of alkyl cyanides, that is CnRCN, the reaction takes place and the product obtained will be primary amine. But in the case of isocyanides, what will be the product? The product will be a secondary amine, and this reaction is known as Menzies reaction. Now, let us see the reaction. CH3CN on reduction in presence of sodium and ethanol. CH3, CH2, NH2. So here we can see that the product obtained will be a carbon more than the parent compound. Okay, it contains one carbon more than the parent compound. Okay, that is ascent of amine series is taking place. Okay, now in the case of isocyanide, CH3NC plus 4H, similar reaction takes place. Okay, CH3 NH2 CH3. Okay, so a secondary amine is obtained. CH3 NH CH3. Okay, secondary amine is obtained. Okay, in the case of first reaction, so alkyl cyanide, a primary amine is obtained, and here a secondary amine is obtained. Okay. Next reaction is from amides. Okay. Reduction takes place in the case of amides. Amides are reduced to primary amines. Let us take the compound CH3CONH2. And the reaction takes place in presence of lithium aluminium hydride or sodium ethanol or sodium in presence of alcohol. The reaction takes place and this gets reduced to CH3, CH2, NH2. Okay, this will be the reaction. Now, plus H2. Next reaction is fifth one, Hoffman bromamide reaction. Hoffman's bromamide reaction. Here the reaction of amides with bromine. The bromine is aqueous or ethanolic solution of sodium hydroxide. So bromine in aqueous or ethanolic solution of sodium hydroxide at a temperature of 343 Kelvin. Primary amine with one carbon less than the amide will be obtained. So this reaction is a stepping down reaction. Stepping down. of the series is taking place. That is, one carbon less than the amide will be obtained. And in this case, the alkyl or aryl group gets migrated to the nitrogen atom. Let us see the reaction. C2H5CONH2, presence of bromine in aqueous or ethanolic NaOH. Reaction takes place, gets converted to C2H5NH2. Okay, NH2 is migrated to the C2 alkyl or alkyl group or aryl group is migrated to the nitrogen atom. Okay, this is propanamide. Okay, plus Na2CO3 plus 2NaBr plus 2H2. This will be the reaction. Okay. Next reaction is Gabriel phthalimide reaction. Gabriel phthalimide reaction. Okay. So here the preparation of primary amine is taking place, and phthalimide on treatment with ethanolic KOH, phthalimide. This will be phthalimide. C double bond O, C double bond O, NH. Phthalimide. Okay. This is phthalimide. Phthalimide on treatment with ethanolic KOH. Okay. Ethanolic KOH. First, a potassium salt will be obtained. That on reaction with alkyl halide, N-alkyl phthalimide will be obtained. Okay, that on hydrolysis corresponding primary amine will be obtained. Okay, let us see the reaction. See, from this we can obtain potassium salt. Okay. Next, on reaction with alkyl halide, RX, this K is replaced by R. Okay. C double bond O, NR. Okay. This is N-alkyl phthalimide. Okay. This will be obtained. This is hydrolysis. Compound obtained will be sodium salt and primary amine. Okay. Plus C double bond O, ONA plus, then plus RNH2, amine. This is primary amine. Okay, primary amine will be obtained. Okay, this will be the reaction, Gabriel phthalimide reaction. Okay. In the case of Gabriel phthalimide reaction, aromatic primary amines cannot be prepared by this process because aryl halides, if we are using aryl halides do not undergo nucleophilic substitution because aryl compounds are highly electrophilic. They do not undergo nucleophilic reaction. Okay, so they do not form aryl compounds. Okay, aryl amines cannot be prepared, or aromatic amines cannot be prepared by this process. And next reaction is reduction amination of aldehydes and ketones. Okay. Reduction amination. That is, by reduction amine is obtained from aldehydes and ketones. Aldehydes and ketones. Okay. Let us see the reaction. Here primary amines are prepared by this method by passing a mixture of aldehyde or ketones can be used. Okay, and a large excess of ammonia and hydrogen gas. Okay, over nickel at 150 degrees Celsius. Let us see the reaction. Aldehyde with excess ammonia and hydrogen okay, over nickel at 150 degrees Celsius and 300 atmospheric pressure. Okay, this aldehyde gets reduced to RCH2NH2 plus H2O. This will be the reaction. Reduction of aldehydes and ketones. Okay.